Hello, I'm Kevin. I'm one of the engineers at Eventual. We build Daft. And today I'm going to talk about how your Iceberg table is already multimodal and how you can use your existing Iceberg catalog and the data that you have in Iceberg to build your AI applications that require data. So starting off with a little bit about me. I'm one of the founding engineers here at Eventual, and I work on Daft. So some of the things that I've done, I've led the development of our Iceberg integration, so I know very well the ecosystem in Iceberg and how Daft is able to work with it. I've also, currently, I'm building APIs for running user-defined models on your data. Before this, I worked in the quantitative finance space where I solved a lot of problems in the distributed data processing and inference in the finance world. I also contributed to the VLLM inference engine where I worked on some optimizations for prefix hashing. So let me start off by introducing two worlds that we have right now. The first one on the right-hand side is our old world. And it's our existing data storage and pipeline solutions. And it's a mature ecosystem that includes Iceberg as well as the variety of data tooling that we have. On the other side is our new world, and that's where our AI data applications live. And the reality is today, we're essentially in the 18th century of AI data. And to get from one world to the other is a treacherous and long journey. So to give more color to that, the old world consists of our robust data pipelines and mature tooling that we know and love. We have very well-established open standards for dealing with structured data. If you have, what file format should we use? Well, Parquet most of the time. What table format should we use? Well, we're at the Iceberg Summit Meetup, so obviously Iceberg. And if you have unstructured data, well, it's fairly simple as well. You store it in an object store. So if you have text, documents, videos, images, just put them in S3 or whatever, and that should work for you. In the new world is where data is needed for AI applications. Applications that really need data are things like vector search, if you're doing RAG, model training and fine-tuning, running evals on your models, extracting structured outputs from your unstructured data, doing things like agentic workflows that require data, and much more. And the challenges today is that, one, there's very high complexity in working with your AI data applications with your existing data solutions. It requires pipelines that chain together many different tools, from reading your data to running your models, and you essentially need domain knowledge across both data and AI to bridge the gap between these two worlds. The second thing is that it's very high in cost. So you have essentially two things that you can do right now for if you want to run models on your data. The first one is calling an LLM provider, which is going to be pretty costly. The second thing is if you want to run your own model, if you want to run models on your own GPUs, that generally is more cost effective, but requires you to have your own hardware that you have to manage, and all the infrastructure and software to fully utilize your GPUs now. You have to think about that kind of stuff. And the third thing is a little more philosophical. There's no good programming paradigm to work with your unstructured and AI data pipelines. For tabular data, there's SQL, which is a great declarative language, but it's not sufficient for AI. On the AI side, there is Python, which has a very strong ecosystem for working with your models, for working with unstructured data. But it's an imperative language, and it's relatively lower level than SQL, which makes it harder for engines to optimize. Say you're writing a UDF for Spark. Spark essentially just treats that as a black box, right? OK, well, what's the solution? Well, since I'm standing up here, obviously my answer is going to be Daft. And Daft is a distributed data engine that allows you to easily run models on your data and work with your unstructured data. And I'll show you how. But not only is it Daft, but it's Iceberg. I think that with Daft, you can actually just keep your data in Iceberg and use Daft to effectively process all of that data without having to move it out without having to build like very complex pipelines, Iceberg can be your single source of truth for both your structured and unstructured data. And with Daft, it can be very effective and very performant to work with that data. So to get started, why don't we hop into a quick demo? So in this demo, what I'm going to do is I'm going to read images from Iceberg. I'm going to generate embeddings for those images with an embedding model. And then I'm going to write to TurboPuffer, which is a very high-performance vector database. So here I have some configurations for setting up my connection to PyIceberg, as well as TurboPuffer. But for the rest of it, we're going to actually write together. So let's get started and just set this up. Shift, Enter. OK, so let's first take a look at what the data is in this Iceberg table. So to do that, let's just create a data frame where we give it table .toDaft, and that gives you a Daft data frame that you can work with. And we can do df.show to quickly take a look at what the data is. And we can see that it has 3 columns. It has a path column, which has URLs to S3 objects, a size column, which is the size of each data point, and then an ID column. So how do we go from that to actually embeddings of these images? Well, first, let's extract the images out of these S3 URLs. And with Daft, it's very simple to do. Let's add a column here. So you go to df.withColumn. And let's add a column called image. And that column is going to be df. And it's very simple to go from a URL to an image with Daft. Path. All we need to do is .download, which downloads the images as bytes. Oops, sorry. Shift. And then .decode image, which takes in a set of, takes in a column of bytes and converts them to our Daft native image type. So once again, let's do df.show to take a look at what that looks like. Oops. Sorry, it's not so easy to code with one hand on the mic. Cool. So it's reading these images from S3, and we have now an image column. And as you can see, Daft actually has a native image column that has native support for viewing these images. And not only can you view like these like tiny thumbnails, but a cool thing about Daft is you can click on them, and you can see a larger version of it. I think with our Wi-Fi right now, it's not entirely working, but yeah. You should be able to click on it, and with better Wi-Fi, you should be able to see a full resolution images. I feel like Mark Zuckerberg here doing this. OK, so going from images, let's now embed them. And to do that, we can import a Daft function to do this. So from Daft.functions. Oh, thanks. Import embed image. And then let's add a new column that's just the vector with the images embedded. So taking a look at this. Thanks, Chan Chan. Oop. Sorry. Let's do df of image. And we can take a look at a sample of the images, and you can see that our images are turned into embeddings, which are, again, a natively supported type within Daft. And finally, let's write to TurboPuffer, and that's as simple as df.select. Let's select the ID and text in this case. The ID and the vector, sorry. Let's not apply a limit to it. There's around 100, give or take, images in this data set. So it should run fine. And then let's do write turbo puffer. Give it our turbo puffer config. Cool. And so what Daft is doing here again is we're taking a Iceberg table of URLs, downloading each of these URLs into images, running an embedding model on these images, and then writing them to our vector DB. Again, the Wi-Fi doesn't seem too great, but I think like in a few seconds, we should be able to see the completion of this. And this is all running locally on my machine. And there you go. So in around 35 seconds, locally on my machine, we're able to embed and write out around 100 images to our vector DB. And we can quickly query this DB as well. This is just a function to generate an embedding of a text. And then let's query this vector DB with, let's try to find like photos of trees. So there you go. We have a set of rows which should correspond to photos of trees. Now let's take our data frame that we had before and let's filter it by these rows just to see if we get the right answers here. Okay. And there we go. We have the top 8 images that correspond to the prompt of photo of trees. And as you can see, it seems to be doing pretty well here. So there you go. So quick demo of going from URLs in Iceberg to images in Daft to embeddings, and then to a vector DB that we can query online. So now that you've gotten a taste of what Daft can do, let's talk a little bit about the future of AI data. So we at Daft believe, first, that the future is Python and AI native, right? You shouldn't need to fiddle with your JVM. With Daft, you can just pip install, and you can get started. Daft also has powerful built-in AI functions for batch inference. So I showed embed image. There's also embed text, as well as a variety of other AI functionality that is optimized for batch inference. And Daft also integrates very well with the Python ecosystem. If you wanted to run your own Python code, if you wanted to run models on your code, on your data, Daft actually allows you to do that very easily. So on the right-hand side, you can see like a upcoming API that we're going to expose to users, which allows you to specify, okay, for your model, how many GPUs do you want? What's the initialization code? What's the code for actually running the model? And then using it with just a few lines of code, right? And it distributes to your entire cluster. Okay. We also believe that the future requires a new execution engine. So instead of having a partition-based execution, Daft actually performs streaming-based execution on small morsels or like batches of like thousands of rows of data each. And the benefit of this is that it improves memory stability because Daft doesn't need to materialize like an entire data set at once into these large partitions. And also it improves pipelining across I/O, CPU, and GPU compute. So why this matters is that, one, it prevents out-of-memory errors in workloads with high inflationary factors. And that's very common when you're working with AI data. To give an example, the demo that I did earlier, it went from URLs, which are pretty small, right, to images, which means that the byte count for an individual row explodes, and then to vectors, which are like in the middle, and then finally writing to vector DB, right? If you're working with like large partitions, this will lead to oftentimes out-of-memory issues. The second one is that it maximizes GPU utilization throughout the entire query, because with streaming execution, you're able to do both GPU compute and I/O at the same time, essentially, with different morsels of your data. We also believe that the future takes the best from the past. So you shouldn't need to sacrifice the power of a traditional query engine just to work with your multimodal data. And with Daft, you don't need to, right? Daft provides a powerful cost-based query optimizer, super fast I/O that's written natively in Rust, and distributed execution that allows you to scale to thousands of machines and petabytes of data. We also believe that the future stores data on Iceberg. Iceberg is great for storing your data, allows for centralized data access with a single source of truth. You don't want your AI data or data for your AI applications to live in a different place from your data for other applications and then diverge. And you can also leverage a mature data ecosystem that provides you the governance, the compute, everything that you essentially need from all the other people that have talked today within Iceberg, right? But you can also use, with Daft, you can store your data on Iceberg and then make use of it in your AI applications very easily. You can use Daft to ingest into your vector database, run batch inference of your Iceberg data, prepare it for training or fine-tuning, and much more. So, in terms of unstructured data, there are two methods that we see people store them. The first one is if you have a column of URLs that point to some files in an object store, and that's the demo that I gave today, right? The benefit of this is that your tables are small. Parquet is built for sort of tabular related data, and so these URLs are very good for that. And Iceberg and most engines are able to deal with that very well. And Daft is also able to efficiently download these URLs in parallel. So there's no performance issue with having your URLs, having your AI data, your unstructured data in a different location from your structured data, because Daft is able to do parallel URL downloads and get that data together very easily. The issue with this is that you need to ensure that your data and access are synced. So if you're updating your tables, you need to make sure that the unstructured data that it's pointing to is also updated. If you're removing fields from your tables, you may have, say, dangling pointers essentially to your files in object store. And so you need methods to clean that up. So the method 2 is just to store data in columns of binary blobs. And this may seem kind of crazy, but it allows for certain benefits. The first one is that your unstructured and structured data access and updates are all unified. If you're updating a row, you know that your unstructured column is also there. Your rows are relatively large, and that sometimes does lead to issues. But with Daft and with Daft's query optimizer and Daft's Parquet reader, the unnecessary columns are not actually read when you don't need them. And so if you're only reading, say, the tabular data and not the unstructured data with Daft, and with several other engines, there's actually not a significant performance penalty here. And finally, it may be more cost-effective, actually, because for a lot of different cloud providers, for some of the major ones at least, the pricing is on per request, right? And so if you're storing these URLs, then you have to make one request per URL, which is relatively costly. But if you're storing them in your tables, one request will take in will read multiple rows. And so you save a little bit on cost. Yeah. So here we have some benchmark results of how Daft performs with some AI applications, with some AI types of workloads. The 4 that I've listed here are audio transcription, document embedding, image classification, and video object detection. And we have these all on our documentation website, docs.daft.ai, if you're curious about the nuances of this and the specific code that we run. But this is all reading from S3 and running models. And essentially, if your data is stored in Iceberg, the performance is exactly like this. So no need to put it into a specialized storage format. Cool. So going back to the picture that I had before with the new and old world, right? Imagine that today we're living in the 18th century, again, of data, AI data, and it takes and it's a very difficult process to go between your data storage and pipelines and your AI data applications. But with Daft and Iceberg, you essentially get the Airbus Beluga of like AI data. Iceberg is essentially like the cargo hold, and Daft obviously is the engines. It brings your like process of getting your data to your AI applications down from months to mere hours, right? Yeah, and that's it. Just a quick note, we're hiring, so if any of this is interesting to you, feel free to reach out to us. And also, feel free to join our open source Slack. Yeah. Open to any questions. Should I be, okay, cool.
Hey Kevin, want to say this is great work. It's really fun to look at the GitHub repository and then play with it a little bit. I guess my question is more on the batch processing side of Daft. So, like in the demo, you were showing more of a like an encoder style model where the input and output size are relatively static. But then what about say for more say like batching for decoding styles of models where the sequence lengths are not aligned within the same batch?
Yeah, that's a good question. So like, I guess like, there's the sort of classical with your generation, you get like variable length generation, right?
Yep.
And then there's also now with like multimodal stuff, you may be generating say videos, and there's maybe like variable frames in those videos. And so the question, the like challenge is twofold. The first one is like, how do you ensure performance when like different like calls to your model will take different amounts of time depending on generation, right? And the second one is like, how do you effectively process that data? Because like with like these multimodal generation, you actually may have like your data may go from like single frames or like prompts to like an entire video, which is like very large, right? The inflationary factor is even larger now with that. And so we're working very actively on one, improving LLM performance. And so I'll actually be giving a talk at Ray Summit in November where we'll talk about a little bit of the internals of how we're doing batch inference to solve exactly the issue that you're talking about. And two, we're working on some new APIs that allow you to say stream or like, if you know like generator functions in Python, be able to yield out like say chunks of text or like frames of video and allow for parallel processing within individual like chunks of your output. Yeah, so.
Gotcha, looking forward.
Other questions?
Just curious, you said this entire demo was running on your local machine.
Yes.
What LLM were you running to create?
Yeah, good question. I'm running the OpenAI clip model. So it's a relatively small model, but you can configure it to use other models as well.
So LLM was not running on you. It was hosted in OpenAI.
It was running on my own model. The OpenAI clip model is an open source model.
Oh, is it?
Yeah.
Okay.
So all of the weights are downloaded onto my machine and running locally.
And then you said you wrote the embeddings into VectorDB. Why not write it to Iceberg?
Yeah, good question. So here's my perspective on this. Iceberg is not necessarily meant for like online applications for like vectors, right? Your VectorDB, TurboPuffer especially, touts like their P99 performance, right? And so if you want like online applications where you're doing retrieval and it needs to hit a certain like latency, right? I don't think like Iceberg is particularly suited for that. I think like the Iceberg committee is looking into adding like vector indices into the format, and once they do, Daft will be able to support that very well as well, but those are for different applications. Those are for more batch applications, right?
I see.
Yeah.
Can you also configure Daft to, I saw on another visual, you could have Daft talk to Fireworks or some other inference provider, and that's doable.
Yeah, so you can configure the inference provider. Provider is exactly the abstraction that we provide for your, for whatever, like the AI functions that we have. So you can configure it to talk to Fireworks, you can configure it to talk to Anthropic, OpenAI, Gemini, whatever.
Okay.
Yeah.
Well, do you batch differently for different inference service providers?
Yeah, good question. I think we're working on certain optimizations for it. Right now, we do not.
Okay.
But especially on the platform side, as we're building out actually a hosted solution, we'll be working on more optimizations relating to batch, right? I understand that there is like an OpenAI batch endpoint, right?
Yeah.
And so like if you can wait like 24 hours for your query to complete, there actually might be like a much cheaper solution for you that we can provide. Yeah.
Okay,
So,
great, thank
yeah.
you.
Any other questions?
Last question.
Yeah, thank you for the great presentation. I have a question related to my previous, where I ended, right? So let's say you have an image which has an invoice, and that invoice I need to extract the values out of it. Can Daft help me and then put it in Iceberg?
Yeah, that's a great question, and Daft can totally help you with that. So
Very good. Okay.
you would use probably a visual language model that generates structured outputs, and we're actively working on having a native structured output function, just like our embed image that I showed, for doing exactly that, for going from an image or going from a text or a document or whatever into, say, your Pydantic base model that you can then write out as like a pipe, like a union or a struct type in Iceberg. Yeah.
Very good. So basically, today with the problem with the OCRs are that let's say you have $100, right, in an invoice. So 100 people write /00, it becomes $100,100. So you cannot rely on OCRs in OCR pipeline. So that's why there is a project for me to enable that. Thank you.
Yeah, of course.
Thank you, everyone. Give Kevin a round of applause.